You are watching channel Number Collage. Through this channel, we make sincere efforts to make you understand and like mathematics in a simple and easy manner. We need your cooperation in this regard. In this video, we will understand the concept of derivative of a function. Derivative is measure of the rate at which one quantity changes with respect to another quantity. Say for example, volume of a sphere is given as V equals 4 by 3 pi r cube. Here volume V is one quantity and radius r is another quantity. The change in volume depends upon change in radius. Therefore, we can say that volume is a function of radius, and we will write V equals f of r. If the volume V of a spherical balloon is changing at a certain speed, then with the help of derivative, we are able to find the speed at which its radius is changing and vice versa. Derivative of a function is a special type of limit. Suppose y equals fx is defined at a real value x equals a, then the limit f of a plus h minus fa upon h as h approaches 0 is known as derivative of fx at x equals a, and it is denoted as f dash a. So f dash a equals limit of f of a plus h minus fa upon h as h approaches 0. The difference f of a plus h minus f of a is infinitesimally small as h approaches 0. F dash a is the change in fx at an instant when x equals a, or f dash a is an instantaneous change in fx when x equals a. Now let us understand the meaning of derivatives graphically. Let us draw a graph of function y equals fx. So x-axis, y-axis, origin, graph of function y equals fx. Consider a point P a comma fa x coordinate, y coordinate. Consider another point Q a plus h comma f of a plus h x coordinate a plus h, y coordinate f of a plus h. Now point Q is very close to P such that its horizontal distance h from P is infinitesimally small. Draw secant PQ. Now slope of secant PQ will be m equals y2 minus y1 divided by x2 minus x1. Difference between y coordinates, it will be f of a plus h minus fa divided by a plus h minus a. A minus a will become 0, so it will be m equals f of a plus h minus fa divided by h. Now imagine Point Q is approaching point P along the curve and its intermediate positions are Q1, Q2, Q3, etc. so that the secant PQ takes the form PQ1, PQ2, PQ3, etc. and ultimately at x equals a, it will take the form of a tangent at x equals a. We also know that slope m of the tangent at x equals a is m equals limit of f of a plus h minus fa upon h as h approaches 0. But this is the derivative of fx at x equals a, that is f dash a. So f dash a equals limit f of a plus h minus fa upon h as h approaches 0. So we conclude that derivative is nothing but slope of the tangent at x equals a. So slope m equals f dash a. In general, for a function fx, f dash x equals limit of f of x plus h minus fx upon h as h approaches 0. This is known as the first principle of derivative. Now let us understand how to find derivatives by the first principle. Find derivative of fx equals 5x. By the first principle of derivative, we have f dash x equals limit of f of x plus h minus fx upon h as h approaches 0. We have fx here. We will find f of x plus h. So f of x plus h will be, we will replace x by x plus h. So 5 times x plus h will be 5x plus 5h. And fx is 5x. So therefore f dash x will be limit of f of x plus h, which is 5x plus 5h, minus fx, which is 5x. So 5x minus 5x will be 0. So we get 5h divided by h. As h approaches 0, h is not equal to 0, so h will get cancelled. We get limit 5 as h approaches 0. Therefore f dash x will be 5. So derivative of 5x is 5. Find derivative of fx equals 3x squared by the first principle. First let us find f of x plus h, which will be 3 times x plus h whole square. Here we have replaced this x by x plus h. So f of x plus h will be 3 times x plus h whole squared will be x squared plus 2xh plus h square, which will be 3x squared plus 3 2s are 6h plus 3h squared. By the first principle of derivatives, f dash x equals limit of f of x plus h minus fx upon h as h approaches 0. Let us put the values. F of x plus h is 3x squared plus 6xh plus 3h square. F of x is 3x squared divided by h. Now 3x square minus 3x square becomes 0. So we get 6xh plus 3h squared. Here we will take 3h common from these two terms. So this will be 3h multiplied by 6xh divided by 3h will be 2x. 3h square divided by 3h will be h. Now as h approaches 0, h is not equal to 0, so we can cancel this h from numerator and denominator. So we get 3 times 2x plus h. Now we can solve this limit by substitution. We will put h equals 0. So it will be 3 times 2x, which will be f dash x equals 6h. So derivative of 3x squared is 6h. Find derivative of fx equals sin x by the first principle method. First find f of x plus h. We will replace this x by x plus h. By the principle of derivatives, we have f dash x equals limit f of x plus h minus fx upon h as h approaches 0. If we put h equals, after putting the values we get, now if we put h equals 0, the denominator becomes 0. So we have to solve the numerator first. We will expand the numerator by the factorization formula that we know. Sin c minus sin d equals 2 cos c plus d by 2 sin c minus d by 2. Here x plus h is c and x is d. So this will become 2 cos c plus d by 2 x plus h plus x divided by 2 multiplied by sin c minus d by 2 c minus d by 2. Here x plus x will become 2x, x minus x will become 0, and we will take this 2 below this h, so it will become h by 2. Now we will write two separate limits. First will be cos of 2x plus h divided by 2, and second limit sin h by 2 divided by h by 2. This limit we can solve by substitution. We will substitute h equals 0. In place of h we will put 0. This limit will be 1 according to the formula that we have. Limit of sin x upon x as x approaches 0 is 1. Now here this 2 will get cancelled with this 2 and we get f dash x equals cos of x. Find derivative of fx equals 5, which is a constant function, by the first principle method. Here f of x plus h will become 5 because there is no x in 5, which we can replace by x plus h. So by the first principle of derivative, we have f dash x equals limit of f of x plus h minus fx upon h as h approaches 0. Let's put the values. 5 minus 5 will become 0, so it will be 0 over h. As h approaches 0, h is not equal to 0, so this limit will become 0. Therefore f dash x equals 0. So the derivative of a constant function is 0. Next, find the derivative of fx equals under root x. F of x plus h will become after replacing x by x plus h under root x plus h. We have derivative by the first principle f dash x equals limit of f of x plus h minus fx upon h as h approaches 0. Let's put the values. F of x plus h is under root x plus h minus fx, which is root x, divided by h. Here, if we put h equals 0, the denominator becomes 0. Therefore, we have to solve the numerator. Numerator contains radical terms, so we will multiply this function by the conjugate of the radical terms. So in the next step, we will write under root x plus h plus under root x divided by under root x plus h plus under root x. Here, under root x plus h plus under root x is the conjugate of root x plus h minus under root x. In the next step, we will multiply the numerator, which will become under root x plus h whole square, which will be x plus h, and under root x whole square will become minus x. X minus x will become 0 and only h will be left. Now this h will get cancelled with this h because as h approaches 0, h is not equal to 0. Now we can calculate this limit by substituting h equals 0, because as h equals 0, h is not equal to 0. So it will be 0 in place of h. So it will be 1 upon root x plus root x. So f dash x will become 1 upon 2 root x. So this is the derivative of root x. Find derivative of fx equals 1 upon x by first principle of derivative. F of x plus h will become 1 upon x plus h by replacing x by x plus h. By the first principle of derivative, we have f dash x equals limit of f of x plus h minus fx upon h as h approaches 0. Let us put the values. F of x plus h will become 1 upon x plus h. In place of fx, put 1 upon x. One multiplied by x is x, minus 1 multiplied by x plus h minus x plus h, x multiplied by x plus h, x multiplied by x plus h divided by h. X minus of plus h will be minus h. X minus x will become 0 and x multiplied by h will become xh. As h approaches 0, h is not equal to 0, so therefore this h will get cancelled with this h. Minus 1 upon x times x plus h. Now we can solve this limit by substitution. We will put h equals 0. X multiplied by x will become x square. So f dash x will become minus 1 upon x squared. So this is the derivative of 1 upon x. So in this video We have understood the concept of derivative of a function. We have understood the analytical and graphical meaning of derivatives and the first principle of derivative. We have also understood how to find derivatives by using the first principle of derivative. We hope you have liked our video. If you did, please click like and share this video. Subscribe our channel. Thanks for watching and have a nice day.